Hey,
Hello,
Bradley.
how are you?
I'm doing okay. It's that time of year where everything's due and everything's happening, but uh, but it's good. But everything's good. How about yourself?
I'm doing all right. Yeah.
Good.
Yeah, it is kind of that time of year. It's kind of the
Oh
end of,
yeah. I mean, for me, it's like I'm graduating from Albany this semester, and
oh,
working, and yeah, just everything's just coming to a head. It's great.
yeah, congratulations on the
Eh,
graduation, everything. Yeah.
Thank you. It's been a wild ride.
Yeah. So yeah, we talked a little bit of well, I got the email about the project and we talked a
Mm,
little bit about that. So
yeah.
uh yeah, that
Yeah.
sounds great. It sounds like it's coming along.
It is, I feel like where we're at right now is that all the little pieces are all done and they're just kind of scattered around and we just got to stick them together.
Yeah.
So I'd be happy to give a presentation on the project and where we're at and where we're going and etc.
Yeah, yeah. We'll do that in a minute actually, if you don't mind. Yeah.
No, I don't mind. Maybe I'll sign on. For some reason, my video on my laptop is out, so I'm using my phone for this, and then I'll use my laptop to present.
Okay, that sounds good. Yeah. Hello, Amanda.
Hey, Amanda.
Good morning. How are you guys?
All right, doing good. What's going on with you? Anything interesting?
Not much.
Okay.
No, I'm glad to be able to join after missing the past few weeks.
Yeah, and yeah, we had a call off our Cognition Futures group meeting last week. It was just
Okay.
we had too much to do. So, but I look forward to it this week. And yeah,
Yeah, me too. I'm really looking forward to being able to be more present moving forward.
yeah,
Very.
yeah. I think we did pretty. I mean, it's a busy time of year, so but
Lots of family stuff.
yeah, yeah. So yeah, so that's good. Thank you for the update. I don't know who else will be here. Jesse might be here, Morgan, etc. So we'll see who shows up. But right now, Brian, if you wouldn't mind presenting on the class project that you um, are working on to bring to completion.
Yeah, sure. Let's see. I'll share my screen on this other account. On the computer, rather. Let's see. There we go. See, this is bizarre. I've got my phone in front of my computer. It's amazing. Oh, okay, there we go, though. Look at that. I can see my screen.
Yeah.
So let's see. Do I have this running yet? Let me just up there. There we go. Okay. So, there. So we've been working on this very subtle and interesting problem, and doing it with Albany students. This is fascinating. So there's lots of little errors that happen just about on everything, but the overall project is pretty exciting. Look at this. I've never seen anything like this.
Huh.
Amazing.
Yeah, it's like, yeah, that's fine, but I mean,
Anyway,
it's like you're in outer space, but yeah.
We'll move on to the interesting stuff. It's just I'm right now. My mind is just so focused on all the little bugs. It's hard to move on. All right. So where we're at with this project is basically that. So we spent the summer working on computational models for promoting open source sustainability in software development communities. So we've been working on this project with the capstone class at UAlbany, which involves myself and 4 other students who've been working to kind of put this together as our final project. And we finally got almost every single little piece done just the other day. And so we're just going to be sticking it all together in the next week. So I'll be really excited, probably in 2 weeks, to really show you where we're at. But for now, I'm happy to show you kind of sort of where we're going. Maybe
Okay.
that's what the best way to say it is.
Yeah.
This page is not operational yet, but we do actually have the GitHub working properly. It just hasn't been kind of slid into the actual site yet. But the idea would be that you would just go back and walk through the steps of things. That you would click here and you would authenticate your GitHub, and that it would populate this model, populate a model from the GSOC this summer with your information from your repository automatically.
Yeah.
These sliders and whatnot. And then the idea would then be that you could sorry, I just lost the internet for a second. That then you could run these models on your community and kind of see what happens. And then the other kind of feature that we're excited about adding to this is being able to save a model with all the information. So that, say you're running a particular type of simulation and you get a really interesting result and you want to share it, you could save that model and it would save all of the NetLogo information and then share it with other people who could run it on their computer. And, all mess with the settings on the left-hand side and whatnot. You could also compare models to each other. Again, I apologize for how kind of rickety this looks, but ideally you would be able to click on one of these and another model would pop up, and then you could share that. We're also planning on getting rid of all of this NetLogo web stuff, so it should be looking a lot cleaner very soon.
Yeah.
I could talk a little bit about the interesting problems that we're having with the project.
Yeah.
But if you like.
Yeah, that would be fine. Yeah, that should be interesting.
Sure, why not? Yeah, I mean, it's brought up some very interesting problems. Let me just share my whole screen so that I can go through some code. So one of the most interesting problems, and I think I spoke about this a little while ago, so apologies if this is old news to most people. Let me just check out the pertinent branch here. Which one is it? Oh, yeah, that's it. So the actual NetLogo files. Oh God. The actual NetLogo files that NetLogo Web produces, or the actual HTML that it produces, are very strange. Let's see. Let me just get this. Sorry. There we are. Are very strange. So unpacking them became quite a process in and of itself, but I was able to kind of break it down into this system called Anatomy of a Model. So we were able to break it down into all the different CSS files and then all the different JS, the JavaScript calls that are happening. They've got jQuery and a lot of other things going on. Oh, did we just lose my screen?
Yeah, I think so.
Bizarre. Okay, there we go. Let's see. Sorry, I'm at a hotel, and so things are a little funny.
Yeah.
There. Oh yeah, it just said something about the bridge channel.
Oh.
Who knows what's going on? I know that this hotel's internet is not working properly.
There we go.
It doesn't really. Anyway, so hopefully that doesn't work again, or hopefully it doesn't happen again. So there are all these JavaScript files that we kind of that I pulled out and put into external files so that we didn't have to look at them, so that we could focus on this, which is just the actual NetLogo code itself. And the initialization part of the NetLogo code itself is down here. You can see this thing that says fetch URL GitHub. Basically the problem that we're having right now is how to inject basically the initial values of like that we get from the GitHub JSON into this HTML file. And it's an interesting problem because the best solution I have so far is that we actually have to rewrite the HTML file itself because it's difficult to dynamically change something that's already inside of a script tag in the way that NetLogo Web is processing this is very, very strange. And I haven't really wrapped my brain around it enough to do it in a way other than just literally rewriting this text. And then, of course, loading this text into an iframe on the actual page. And so something else that's been going on with this project that is interesting is that I've actually been continuing to work on the computational models using as a project in my Bayesian data analysis class. So that's been pretty interesting. So I'll be able to report on that next week. I've kind of written the abstract for it and have started to do the work, but I haven't coded up the model yet. But basically, I would be using Bayesian analysis to like applying Bayesian techniques to kind of further investigate the probability that that a community is operating sustainably, or the probability that an agent will or will not continue to want to be part of the project, basically, to continue to cooperate.
Yeah. Well, that's great. Yeah.
Yeah. Yeah. No, I mean, who knew that this one project would have so many some tendrils?
Yeah, I know. It's great. I was really impressed with some of the stuff over the course of the semester. I've seen, everything coming together, getting this on the web and getting especially the model comparisons and getting that up and running, because that's can be difficult to have that in one place.
Exactly.
So,
and like you were saying before, I think a couple weeks ago, maybe, what we're trying to do is extremely subtle. Like a person using this, it shouldn't, it should look very easy.
Yeah.
But on the end, it's actually it's a lot of very complicated kind of sorting through lots of different protocols and APIs and whatnot. So it turned out to be a pretty wild project, even though it's kind of a simple idea.
Yeah, and I kind of hope it gets some steam. I think people will use it.
Yeah.
But yeah, it looks good.
Yeah. And something I always hope that Himanshu or Hussein will be here for the meeting when I'm talking about this, so that I can try to pull their models in. Especially Himanshu's. I think my models are purposefully fairly simple, whereas Himanshu's, I think, is a bit more comprehensive. So I'd really love to be able to integrate their work into the site. And I have gotten Himanshu's permission. I would want to talk to him about the details, but I'll talk to him.
Yeah, I think probably, it's a good idea just to get it up and running with one model and then see, we can build on to that. It's not, I
Right.
guess for proof of concept, really, it's just you want to start small. But I think it's coming along nicely. I think the idea would be you'd go in and we could advertise it as a site for people to go and use it for their needs. And I don't expect it to be like a huge amount of traffic, but it's for what it for the niche area that's trying to serve, it might become a pretty indispensable tool. So we'll see what people think.
Yeah, I mean, it's the whole world of computational modeling is so interesting because it feels like what's the right word? I mean, to me, as the person who has been kind of behind it, it feels like, oh, this isn't real though. Like, this isn't right. Thinking about people using it, I'm like, really? What? Are they actually gonna get? Oh God, So that's the other reason why I'm continuing to work on the model. Actually, because I think that they can be improved and refined. And that's actually something else about this website that could be really useful, is to get feedback on, like, well, I ran your models and I got this out of it, but this part confused me, or this part seems strange. So I'm really excited to get this thing up and running, and then start really doing the more work on the computational side.
Yeah, I think so. Yeah, I think it's a matter of like really kind of getting people into it. I mean, I guess I'm trying to think of how like some of these resources start. You build it, you get it to a point where you can actually have people use it. Well, we'll talk later about the AI platforms that people are using, but you maybe put out a demo, or in this case, you could just put out an actual, like, come and use our tool, and then people can come and use it, and they'll have feedback, and maybe it gets refined after that. But I think it's you got to start at a place where you can get people to actually use it and try it out, and
Yeah.
you can't assume that people are going to use it a certain way. You have to give them a little bit of freedom in how they implement it. But at the same time, it's like you have to give them some instruction on, this is the best way to do things, sort of like a tips and tricks. And then, they can get the most out of it, especially with something like this where it's like pretty abstract and you don't know exactly how to map your problem to it. So that's, and I don't know, maybe the answer there is like, we may need to maybe it's as a GSOC project or something else, and be a student project where we have people write documentation for it. So like as people use it, here's some documentation on how to best use these models, or how we might build a better model, or how we might, what do I use? Do I use like RL, or do I use active inference, or what am I using, and why?
Right.
You know,
Right. Exactly. And that is a whole other aspect of the project that we just, because the subtleties of the back end stuff became so overwhelming, we weren't able to do another aspect of it, which is to kind of write an extension for NetLogo Web that enables us to run Python code in the tool. So I do have a server with Python on it that this runs on, that theoretically we could use. Since our web development backend Flask is based in Python, we could kind of, for lack of a better term, maybe like, so if this is the internet aspect of it, kind of open a hole to the Python backend and inject the Python code for the models through there. It's possible, but we have a chance to do that yet. So the active inference model and the reinforcement learning models at the moment will not run properly until we do that.
Okay.
Just totally clear about that. Just like right now, I can only run my non-Python models. So it's sad, but it's where we're at.
Well, yeah, I think this class project is really just to get the interface up and running. I mean, you can't do everything in one semester.
Turns out.
Yeah. Yeah, but I mean, that would be like, a next step. Like we talked about in GSOC, you have these different levels of like different goals that you want to have. You want to have the immediate goals, and then you want to have the higher level goals. Like, I think we classified them as moonshot and Mars shot and Jupiter shot or outer space shot, that sort of thing.
Yeah.
And they're all different scales. So if I
Right.
Want to just do some tweaking of the code, that's a pretty immediate goal. But like building a whole new module, it's a higher order goal, and you want to make sure that you get the low hanging fruit first. But sometimes that's deceivingly hard. So you have to prioritize these things.
Absolutely. Yeah. Very wise.
Yeah. But yeah.
And
yeah, go ahead.
Oh, I was just going to say, I've also been talking to a friend who's in a PhD program in philosophy at CUNY, and we've been discussing conceptual engineering and doxastic cartography. And so this is in relationship to the Cognitive Futures group.
Okay.
And so she's been sending me some fascinating fascinating readings that I can start sharing with the group if you want. I mean, doxastic epistemology, doxastic cartography, and conceptual engineering, and it's one of those fields that's developing. And I don't know if you've heard anything about this, Amanda, in philosophy, but it sounds like it's one of these things that's developing right now, and that has obvious implications for cognitive science, for AI. In particular, she's been talking a lot about the work of a person named Nicholas Shea, who apparently writes a lot about structured representations versus representational structures, and what the difference is, and how they apply in artificial intelligence specifically, but in computational modeling more generally.
Yeah.
So
that's interesting. I'd heard Shay's name before. I had not heard the term doxastic cartography. That sounds really interesting.
Right? Okay, I'll start sharing resources.
Yeah, for sure.
It almost sounds made up. I mean, like...
Yeah.
I actually asked ChatGPT what it was, and it gave me a pretty good definition.
Okay, well, there you go.
And then I asked it to explain it to a child, and then that was very interesting. I love ChatGPT. I've been having so much fun playing with that. And it sounds like maybe, Bradley, you're going to talk about that later.
Yes, actually. So yeah. All right. Yeah, please share those with the group, and yeah. Okay. Looks like Brian froze up a little bit. Oh, there he is. Okay. So yeah, I guess we don't really have anyone else coming in right now, so we can move forward with some of this. I'm going to talk about a couple news items, and I'm going to actually talk about ChatGPT. So let me share my screen. And of course, this week, Jesse was able to attend NeurIPS in a limited fashion. He didn't actually go to the conference, but he caught some of the stuff virtually. And I'm going to go through a Notion document that he made. So let me share my screen. Okay, so the first thing I wanted to talk about was, several weeks ago I talked about stable diffusion. And this is, of course, text-to-image AI. So you give it a text prompt and it generates an image. So in this case, you're generating an image. This figure here, figure 1, this is image generated with the prompts, a high-quality photo of an astronaut riding a horse/dragon in space. So this is like you give it a text prompt and it gives you these images that it generates. And this is a nice technology, and a lot of these kind of text-to-image technologies have used, very high-end computers. You have to basically give something in the cloud a prompt and it gives you images, but you can't run it locally. Well, with Stable Diffusion, because it's open source, you can run it locally. Now the question is do you have enough computational power? And several weeks ago, I talked about some cases where people were getting this to run on Apple Silicon, which is like the M1 chip or M2 chip. So if you have a Mac where you have that kind of a architecture, you can get this to run on its own. So that's an advance. Now, I was showing you people hacking it, so to get it to work. But now Apple Machine Learning Research has actually put out the source code on their GitHub. So this is actually something that Hugging Face, I think I mentioned that Hugging Face was working on a version of this, and it looks like they've actually made it, it's made it into a release. So this is the GitHub site here, Apple's GitHub ML Stable Diffusion, and this is the Core ML Stable Diffusion, so you can install this on your Apple Silicon machine and try it out. So it's nice to see that they've actually been able to get it to a point where you have a release that you can start using it and experimenting with it. So if you can do that, I mean, I could do it myself, but who has the time? No, I'm serious. Seriously though, I'd like to try it out at some point. I think it'd be really interesting to see what can be generated. And you can do this, I guess, online, but this is nice to have your own version of it because, you can control, you can even modify it. You can control access to it and you can modify it and things like that. So that's just to point out that that's available. The next thing I'm going to talk about is this article. This is by Patrick Minial, who's a person affiliated with Neuromatch. And he has this blog, XCore. And so this is computational neuro and AI. Writes on a number of topics in this area. And he wrote this article recently. I don't know if this was recently or if this was like a re-up of an older article. But, well, actually, it's from May of 22. So it's from this year. And the title is What's the Endgame of NeuroAI? And so NeuroAI is this area where you're taking neuroscience and neuroscience inspired models and you're merging them with AI. So you're merging them with like the text to image or the text querying, which we'll talk about with ChatGPT, large language models. And, but some people think that, those type of models that might use things like, NLP or reinforcement learning are sort of, good enough. But other people think that, you need neuroscience inspired approaches. So this is sort of motivating this question of what's the end game of NeuroAI? Is it to simulate intelligence, or is it, something else? Or is it to compete directly with these kind of models where we're trying to generate something that looks like it's intelligent? What exactly are we trying to accomplish with this? So the article, going through the article, it's been 60 years since Hubel and Wiesel first started unlocking the mysteries of the visual system. And we talked about those papers. These are the ones where they explored the visual representations in V1, which is the lowest level of the visual processing system, where you're taking in information, visual information, and it's being represented in V1 as a series of stripes or rudimentary patterns. And so you can see the organization of the area, you can see what it's representing. It represents these kind of blobs of the visual system, stripes in the visual system, and so forth. So people, that was sort of the beginning of unlocking what the visual system was doing with information from the environment. And of course, that internal representation is important for AI systems to understand what AI systems are doing when they take information in and then produce classifications. So Hubel and Wiesel actually were exploring this sort of in a very reductionist way. They're exploring it as, a neuron by neuron approach to visual cognition. So they weren't really focused on, visual processing as an emergent phenomena or as something that's, larger than single units processing information. So proceeding one neuron at a time, they discovered the fundamental building blocks of vision, the simple and complex cells. So there are different cell types in this region of visual, in the visual processing center that they were looking at. And so they were able to find these fundamental building blocks. Yet for a long time, neurons in high-level visual cortex were something of a mystery. So high-level visual cortex are areas. So V1 is like the sort of the base of this visual processing stream. It processes things like blobs and stripes and other features of a visual scene. If you go further up to V2, V3, V4, you start to get different aspects of it. Like you start to get semantic integration, you start to get multisensory integration, you get other things so you get like higher level processing and you get higher level representations of the visual scene. So this is an important part of this visual stream because it branches into two parts, the ventral and dorsal, and you get these different, sort of additions to the visual representation. So this is actually maybe a more important part of visual processing, but it's something that we haven't explored as much. So what he's asking here is what kinds of neural computations support complex, flexible behavior. So in 2014, when he defended his thesis, he confidently stated that we did not know how to build computers that could see like humans do. So all that stuff I just described is sort of, sort of the sum total of human visual information processing. You have to have these two visual streams. You have to have this complex set of centers where things are put together, and then we can interpret visual scenes. And we didn't really know how to build computers. We knew a lot in 2014, as we do now, about these different aspects of neural processing, but we didn't really know how to model them in a computer. Yet only a few months later, so this is 2014, a few months later after he defended his thesis, Nigo Kregis-Corti and Jim DiCarlo's labs showed that deep neural networks, DNNs, trained on ImageNet represent visual information similarly to shape-selective regions of the visual brain. So shape-selective regions are kind of like this V1 area that I mentioned. Follow-up research, including some of my own, increased the number of visual areas that could be explained this way, while also decreasing the numerical gap between brains and computers. So in this conception of NeuroAI, they're focusing on the visual system. They're focusing on how we process scenes in our brains. And then they're focusing on how that can be simulated using neural nets. Which is, one type of representation that one can use, one type of computational tool, but we can do some interesting things with that. And maybe that's a way to simulate this. Maybe we don't even want to mimic the brain, though. Maybe we just want to use neural networks more generically. But it looks like here you can use neural networks to sort of get a good approximation of how the brain is doing this. There are some remaining qualitative gaps covered in Grace Lindsay's review, which is here. This is convolutional neural networks as a model of the visual system, past, present, future. So this is kind of a review of this area of using convolutional neural networks, or CNNs, to look at biological vision and understand it better. And this is a nice article if you're interested in this area. But there are some problems with this kind of approach. So DNNs are more susceptible to adversarial stimuli, for example. So if you give the DNN perfect information about the visual scene, it works well. But if you start to give it adversarial information, like patterns that look similar to the target pattern but aren't, or things that it's not seen before, you can think of adversarial stimuli in a number of ways. It could be just noise. It could be something like what I just told you. It could be like almost like a magic trick. You try to fool a network with something that isn't the target stimulus that you're trying to train it on. So there are a lot of ways you could view adversarial stimuli, but they're very susceptible to this. They require far more training data than brains. They're biologically implausible in that they don't follow Dale's law, whatever. I don't really know what Dale's law is, but they're not as biologically plausible as real brains, which you might have guessed. As I argued in my previous post, which is something he wrote on unsupervised brain models, people are working on all these fronts. We will be able to build a comprehensive in silico version of the visual brain over the next decade. What next? So this is the argument here, that we've made a lot of progress on the sort of neuro approach to AI, that we can use the brain as sort of a metaphor for, how we process visual information. We can build a computational model of this, and then it behaves sort of like the brain. And then if we can master this, then what? Why are we doing this? What's the point? And, maybe even with these flaws, it's maybe a good way to approach AI, but maybe not. So in this essay, I will argue that we should build over the next decade an in silico version of the visual brain that will unlock a whole array of applications in human health. We'll be able to exercise fine control over our visual experiences and this will enable therapies delivered through the visual sense. Some therapies will be applicable for people with neurological disorders, while others will enhance healthy people. It will be unlocked by stages of technological development, first at the maturation of NeuroAI, then through consumer augmented reality, and then finally much further down the line with brain-computer interfaces through its closed-loop control. So this is an interesting sort of approach to NeuroAI. So, saying you can simulate the brain is interesting, but what can you do with it? He's arguing that you can use it to explore therapies, explore sort of neurorehabilitation, and then, moving into things like augmented reality and then brain computer interfaces and applications to that. So you're building this model of the brain, and then you're saying, well, now we can interface this with technologies that we might use for real brains. So, like if I want to optimize, say, for example, a brain computer interface, I can use a NeuroAI model and test out different scenarios with the brain computer interface. You could optimize, for example, closed loop control with these neural systems. You can do this in silico, and then you can actually apply it to actual brains. So that's an interesting view of NeuroAI. So again, it's not just about simulating intelligence. It's about using that information or using that knowledge to drive some of the things we do with like neurotechnology and with treating, disorders and other things. So he's actually covering a number of different topics. I'm not going to go down all the way to the end because it's a pretty long article, but he covers a number of different topics. He thinks that NeuroAI models will keep getting faster and better. It's more than a satisfying intellectual exercise, but it can actually help people. We want to focus on things like larger scale questions like visual communication and control. So communication and control has always been a key part of this type of approach, and it kind of goes back to cybernetics, where we talk about communication and control. And this is, of course, true of a lot of these AI models, and especially NeuroAI models, because they do involve a lot of feedbacks, and it involves a lot of control over information. So, and we need to understand these principles of how this works, and then how those things change when you actually have like an application, where you have something like a brain-machine interface, where you're interacting with the world, and you have to understand how that technology works, even though you may not understand every aspect of the biological system. And then what are the technological trends that will unlock these NeuroAI applications? And he focuses on augmented reality and brain-computer interfaces, and then this idea of closed-loop control. So, when you have your artificial or your augmented reality system or your brain-computer interface system, you're basically interacting with something that's outside of the brain. So you're taking things from the brain, you're interacting with the environment, and you're giving feedback. And that feedback loop is closed because, you would have that normally in the brain where you would interact with the environment, but you have this element of it that's sort of highly controlled that's outside the brain as well. So this is an interesting question, and something that, I would add here, not just augmented reality, but virtual reality, and other types of technologies that are kind of coming out of that. So I think that's a nice article. It kind of goes over a lot of different things. And that's something that we can talk about more, or we can sort of base some further discussions off of. But I thought that was an interesting post, especially like a lot of the stuff we talk about with brain inspired approaches to this, because it's one thing to do them and to be able to show a proof of concept. It's another thing to say, what is it good for? Why are we doing this in a broader sense? Looks like Jesse's here. Okay, so, this is interesting. As Brian said in the chat here, ask ChatGPT to explain neural nets as if it were drunk. So it says, so this is this is his question that he asked, and we'll get into ChatGPT in a minute, but this is the answer that it gave. Generates an answer. Oof, okay, so a neural net is like a big tangled mess of neurons, kind of like a ball of yarn. But instead of being made out of yarn, it is made out of math, with an exclamation point. And instead of being all tangled up, it's really organized and nice. It's kind of like a brain, but instead of thinking and feeling, it's really good at solving problems and making predictions. And instead of being inside your head, it's usually inside a computer. So there you go. A neural net is like a brain made out of math that lives inside a computer and is really good at solving problems. How's that? I think that's great. Yeah.
I thought it was actually pretty good.
Yeah. So that's great. Yeah, it's
Made out of math is actually very funny
Yeah.
and interesting.
Okay. So yeah, actually, that brings me to the next thing I want to talk about, which was the whole Chat GPT thing that happened this week. So it kind of got released this week. Let me see. So I have some interesting images from our Slack. The one was okay. That's not the one. So this was something that I think Brian asked a question. Let me go to the Slack here. Brian asked, or I guess he was playing with it, or some people he knew was playing with it. I was playing with it a little bit this week, but so this is the example here. Someone asked the question, give a step-by-step analysis of the worst-case time complexity of the bubble sort algorithm with Python code examples, but write every sentence in the speaking style of fast-talking wise guy from a 1940s gangster movie. So that's a pretty specific, so it's asking it like to give an answer, but it's also asking it to do it in a certain style. So if you go back to these images that we have for, I don't know if it's open anymore. Okay, for the text to image generation, it will do some, you describe the image you want to see, but it also does some procedural generation of the style. So this is, not just like matching the description that you give it. Like, I want to see a dolphin riding a horse. It could generate that image, but it also generates in different styles. So this is doing the same thing, but with a large language model. So this is the underlying technology here is the large language model. It's also using some other techniques as well. So this is just keep that in mind when you hear this answer. So this is the answer. All right, pal, listen up. The bubble sort algorithm, she's a real simple one. But the worst case time complexity, that's a whole different story. You see, in the worst case, every element in the list got to be swapped. So the time complexity is going to be proportional to the square of the length of the list. Get it? Here's some Python code to help you out so you can see if you can follow along. And then this is the Python code. See, in the worst case, well, the loop is going to keep looping until there ain't no more swaps to be made. In the inner for loop, it's going to go through every element in the list. So the time complexity is going to be proportional to the square of the length of the list. Get it? And Amanda said, what a time to be alive. Yeah, it's definitely great. And so then apparently someone also gave ChatGPT an IQ test. So this is the IQ test for ChatGPT. It's achieved the following scores. General intelligence quotient 83, which of course so the average population average is 100 on those tests. Arithmetic 83, spatial skills 72. I don't know how they assess these exactly, but these are the numbers they got. Logical 78, spelling 86, short-term memory 82, rote utilization 82, algebraic 83, general knowledge 78, visual apprehension 78, and then computational speed 105. So intuition 82. So, it's, I guess, I don't know how you really assess intelligence with an AI, but it's below the human population average, but it's definitely, we could talk about measures of intelligence and how those can be fraught with issues, but that's the test they gave it. And so, and then this is another, actually Morgan pointed this out, that someone made ChatGPT give a full SAT test. So they gave it a full SAT test and it scored a 1020. 500 on the math, 520 on reading and writing. So, that's not, you're not going to get into Harvard like that, but it's all right. All right. So, yeah, so I just have those pictures in this. Let's just kind of go over that. So ChatGPT. So this is something that OpenAI has released. They released it this week. And if you have to create an account at OpenAI to use this, but you can just log in at chat.openai.com and try it out. So they give you some instructions. Unlike the Galactica example we did 2 weeks ago, you have some, like when you log in, and I logged in already, they give you some sort of ground rules for using it, and then you go over it, and then it gives you these examples, capabilities, and limitations. So it kind of gives you some explanation here. So if we use this one here, explain quantum computing in simple terms, which is not very fun. Put it in the window, and it generates some text. And so it's using a large language model, and there's some bells and whistles on it, but it's basically a large language model. So you're querying it, explain quantum computing in simple terms. And the answer it gave is quantum computing is a type of computing that uses quantum mechanical phenomena, such as superposition and entanglement, to perform operations on data. In a classical sense, in a classical computer, data is represented using bits, which can have a value of either 0 or 1. In a quantum computer, data is represented using quantum bits, or qubits, which can exist in multiple states simultaneously. This allows quantum computers to perform certain types of calculations much faster than classical computers. So when it's confronted with like this idea of quantum computing, it can do, and then it does it in a style, simple terms. If I said explain quantum computing, let's say like a robot, I don't know, what this is gonna do. So now it's gonna give me a different answer. Actually, I don't know if it's a different answer. I think it's basically the same answer.
Yeah, it seems like sometimes it can't kind of stylize certain things for some reason.
Yeah. Let's see. Like a gangster, maybe.
Yeah, love that. Have you tried out generating code with it? Because that's really what has been blowing my mind with it. If you say, for example, like create a Flask app that hosts a NetLogo web file in an iframe, it can pretty much do it.
Really? Okay.
Yeah, it's pretty bizarre.
Yeah, it's interesting because it's like that's not something you'd think a large language model could do. Although, like I said, it's not a straightforward large language model. There's some aspects they do other things with it as well. So explain quantum computing like a 1930s gangster, and this is of course just like kind of what we saw with the other example. Okay, imagine you got a bunch of guys working for you doing all sorts of jobs, but instead of being able to do one thing at a time like a regular guy, each of these guys can do multiple things at once. This is kind of like how a quantum computer works. So, you get you can do stylistic variations, you can do explanations. One thing you can't do is search for people or for places or for things. Like if you wanted to say, who is where, let's say, what is Saturday morning NeuroSim? I don't know, maybe it'll come up with something here. It'll say, I'm sorry, I don't have information on this, as my training only goes up to 2021, and I'm not able to currently browse the internet. Can you provide more context or details about what you're asking? So it looks like it's being trained on a data set that sort of ends in 2021, but it also can't browse the internet to look for answers. So let's see if I can do some code. What do you think would be a good thing to do for code query, Ryan?
Let's see. We could ask it to, well, I mean, I'm kind of tempted. Okay, how about if we ask it to write a Python program that solves the there's like a neural net program that solves the NAND. Write a Python program that trains a neural net to represent a NAND gate. How about that?
All right.
Just off the top of my head, I don't know.
Yeah, I know. It's okay. So here's one possible way. Oh wow, it's really doing. Yeah, look at this. This is great.
It's amazing.
Wow, that's pretty efficient. I was like, okay.
I've never seen anything like this. So
yeah, so this is the program he came up with, and it looks pretty efficient, and something you plugged right into a notebook and run. So you're importing TensorFlow, you're defining the inputs and expected outputs for the NAND gate, you're defining the model itself, and this is using Keras, and then you're compiling the model, and then training the model, and then testing the model. So there you go. And of course, you'd probably have to do some other things here in terms of refining the code or putting other code in place for it, data sets and so forth. But this shows you basically how to do it. This program uses the TensorFlow library to define and train a simple neural network with 2 inputs and 1 output. The network uses a sigmoid activation function and is trained using binary cross entropy loss and the atom optimization algorithm. After training for 1,000 epochs, the model should be able to accurately predict the output of NAND gates for any input. Okay, that's great. And I'm thinking, let me try a recipe here.
Oh, there we go.
Yeah, I know. Let's see. What should I look for? Recipe for like sugar cookies. Let's try that. Yeah, we got a simple recipe for sugar cookies. Wow, that's good. So it gives you the ingredients and directions, and this is see if it does this. Okay, yeah, there we go. A recipe for caldo, which is like a type of super stew that you would find in Latin America, say. And it gives you, I was just trying an ethnic dish instead of like sugar cookies, which might be a more generic thing. But you can get this. This is a simple recipe again with the directions. What else?
I just asked to write an essay on the philosophical concept of doxa, and it did.
Oh, it did. How do you spell that?
Oh, doxa, DOXA.
All right, there we go. Doxa plays a significant role in the philosophy of ancient Greece, particularly in the works of Aristotle and Plato. Aristotle, for example, argued that doxa is a source of many of our ethical beliefs and values, and that it can serve as a starting point for philosophical inquiry in the pursuit of knowledge. Plato, on the other hand, saw doxa as a hindrance to the pursuit of truth and wisdom, and argued that it is ultimately the job of philosophers to challenge and transcend the beliefs and opinions of the masses. So this is good. It does a pretty good job. It does seem to have a pretty large training set.
And what's interesting is that the essay that I got is completely different from the one that you got.
Really? Okay. Yeah, that's the next thing I was going to test was reproducibility. So I was going to ask the same question a couple times, and I don't know if it's the instance or let's try it again. I mean, this is just like. Okay. Huh. It's giving me more or less the same thing, but.
The only difference that I did in my prompt was I said, write an essay.
Okay. Let's see.
So I don't.
Yeah, it's interesting how it interprets like.
Yeah.
I mean, I guess the prompt is very important. I mean, like the getting the prompt exactly right. I mean, there's this whole idea of prompt engineering, which is like where you have, you spend time engineering the prompt and like basically figuring out how to ask the question. Okay, so yeah, this is different, but it's writing an essay as opposed to like say just essay. And I misspelled essay there, so that's probably it's robust to that apparently. But yeah, I mean, it's definitely. It does seem like it has like some reproducibility. Like if you ask it twice or three times, it'll basically give you the same answer. If you phrase it a little bit differently, it gives you a different answer. But that's that's the idea of the well-posed question, right? Like if you ask your question more in a more specific way, you get a better answer. And that's. But I don't know. So this is fun to play with. I like how it gives really good answers. It gives code. It gives like recipes. It gives, you can't really ask it about people, places, and things too much because it doesn't have that training set. So the training set I imagine is like a dictionary or encyclopedia of knowledge. Um, and then, it can't search the internet. So it can't find trivia. Like, I asked it my name earlier this week. It couldn't identify me. So, well, unlike Galactica, which thought I was a Puerto Rican basketball player, I don't know. Yeah, I don't know if that's like how it was getting that is generating. But what Galactica does is it generates these little Wikipedia style pages, and I don't know what it's drawing from for that. Maybe it's just getting like general information about things like your name or whatever. But it's other than that, I don't know. But yeah, this is great. I like this. This is very good. And I don't know. Then the question is how do we use this? So what could we use this for? A lot of people have mentioned like you could use it as an extension of your research. I could say, for example, if I'm writing a paper, I could plug in like a sentence if I'm stuck on an idea or concept, and I could figure out what's going on. I could ask it about things like a philosophical idea, and it can give me some information about that. But I can't really ask it about people or certain types of trivia. Um, it's I guess good at completing text. So if you want to ask it like, give me something in the style of what I'm doing, it might be able to do that. Yeah, so I mean, I really don't know what the limitation. I don't know how you might use it creatively. I mean, that's probably pretty much up to the person. Um, and then, of course, we can actually assess, different styles. So we can say, give me something in the style of this thing, like, some gangster from the 1930s or, Star Trek. I don't know. But it's really interesting how it interprets that, and I can also do style generation, procedural generation.
I'd also seen someone who I don't remember what the prompt they used was, but it was they invented a new philosophical concept and like a fictional philosopher named Herbert something, and I guess his idea was called dynamic canonicity. And it had something to do with. It's just really fascinating. Oh, love it.
Is that like a literature thing or canonicity?
Well, yeah, canonicity being, what, yeah, I think it's a literature reference because, like, yeah, something is part of the canon. Like the Bible's part of the canon. We all know it is CANON instead of NNON.
Yeah. That's great. Yeah, I mean, that'd be a really nice tool for like digital humanities. And, it's like you have, that's basically what you're doing. You're trying to analyze like literature and some of the other humanities using computational tools. So, yeah, this is great. Let's see, we have some things in the chat. Oh, go ahead.
I was about to say the same thing. Go ahead.
Oh, yeah. So Jesse said, I put something in the pedagogy channel as well, no voice for a while. Amanda said, "Glad I quit teaching philosophy, but we're having to deal with bot-generated papers."
Yeah. So my thought seeing this was, well, now like a plagiarism checker can't check that. So I was thinking like, if I were still teaching philosophy, if it were completely online, like how would I actually evaluate a student's knowledge? Like if it were in person, that's easier because you can, I guess Zoom, you can do the same thing. Like I feel like I'd need to in real time, like have a conversation with a student, and that is now like the only possible way to like guarantee that you are to like actually evaluate someone's knowledge. Because yeah, these that can definitely write a paper that is an undergrad at the undergrad level, far above it.
Yeah.
So that's kind of scary in that context of like the future of education in the humanities. If students really don't have to I think a lot hinges on what questions you're asking. So I still think that maybe you could get around, maybe you could still force students not to use a bot by asking the right questions. But I don't know, maybe not. At least like in 10 years, maybe not. Maybe like a bot could really do like much more sophisticated work, which is cool, but not from like an education standpoint where you want the bot to be a tool once you are already at a certain intellectual level and you can use the bot as a tool. But if you're trying to learn how to think on that level, having something that can kind of do it for you is will be very tempting for students.
Yeah, and actually that was what people were talking about, like online about this, like where they were talking about like, oh, this is going to be really hard to check. It's like plagiarism is one thing, but this is another thing. Just plug something and get an answer and turn it in. And then there's no, I mean, I guess you could go and check GPT-3 to see what answer it gives. But that, what,
right,
what
but if it can be
have.
different each time. Yeah, I was trying to think like if I were still like in philosophy and committed to teaching, I think in-person interaction, I mean, that's always been important, but that'll become especially important, like having a physical classroom and interacting with students in the real world in real time.
Yeah. Yeah, it's just like giving, asking people to regurgitate something or, saying, send me a answer. That's probably not going to be as effective. Although, yeah, I think there's a lot of teaching. It's like kind of, direct, in philosophy, of course, especially there's like a lot of this sort of discursive stuff where you're asking questions and like, Socratic inquiry where you ask a question about a question and you give answers and you have to sort of evaluate each one. And
the dialogue in the classroom will be especially important. It's already very important, but like teaching online, you can kind of get around that with like discussion boards and stuff, but not really anymore, I guess.
Yeah, and it also makes me think of in the software engineering community. I mean, if somebody who's a senior software engineer doesn't have to call a junior developer and say, hey, make me up a Flask app that includes a NetLogo file, if instead they can just write into the GPT like, okay, do that, and then it just spits it out, there's a lot of jobs that are about to be compromised.
Yeah.
But honestly, that's exciting to me. Like
that, that's kind of fine.
Yeah.
That doesn't like scare me in the same way that it does in the education context.
Yeah.
I agree.
Although, well, if you're teaching computer science, you ask someone to build a program, and they just but they do that now with Stack Exchange. Yeah, like you can just go on Stack Exchange and find code, or one of the other someone will ask a question, someone will also put code in, and you'll say, this is the best answer, and they just copy the code and modify it, which is not like horrible in the context of computer science education, because the kind of the idea is like to get an answer and then, modify it for what you want. And so it's not like, it's kind of like doing research. You find like something in the literature, you find something else someone did previously, and then modify it for what you want, and then answer the actual question that's being presented. So if I want to write a program to do X, you might be able to find something like that online, just, line for line, character for character. But a lot of times you have to figure out how it works in order to get the exact answer that the instructor is looking for. And then in philosophy, I'm not sure if that's something that, like, because you're just asking for, you're asking for people to think critically. So, I don't know, there are ways around, like, kind of just getting people to regurgitate things and saying, well, that's, because if you notice, like, things that it gives answers kind of like at maybe a high school level essay, or maybe even a middle school level essay. It's not like it's giving these really thoughtful answers. It's just kind of giving a basic factual regurgitation of an answer. So, I don't know. But if an instructor is like looking at this and saying, well, this is something that maybe is C work or D work, versus like, oh, this is brilliant. There's something there that's like maybe not something that the model can reproduce.
Yeah, what happens if you ask it to like give you an argument, like a valid argument, like give me a conclusion and support it with premises?
Right.
I wonder if that's something that it can do, because that's really like the skill.
Should we try?
Trying to teach in philosophy. If there's time, I
Yeah.
guess we could
Well,
do this for the whole meeting.
How would you
do this?
structure this query?
Like, I don't know, construct an argument in favor of. It kind of like doesn't matter what it is. So I'm trying to think of something that isn't like some philosophical concept, but just how about dualism?
Okay. Oh, yeah. Okay. Yeah, it's working. Let's see. All right. One argument in favor of dualism is that it can help explain the existence of consciousness and the subjective nature of experience. Dualism posits that the mind and body are two separate entities, with the mind being responsible for consciousness and subjective experience. This idea is supported by the fact that we have a clear sense of our own consciousness and experience that we have such thoughts and emotions and perceptions, but no direct access to the workings of the physical brain. And has another argument in favor of dualism, that it can account for the fact that mind and body seem to interact with each other in complex ways. Dualism offers a possible explanation for this interaction. A third argument in favor of dualism is that it can provide a more satisfactory explanation for certain phenomena such as near-death experiences, psychic phenomena, and out-of-body experiences. These phenomena are difficult to explain from a purely physicalist perspective, but can be seen as evidence of the existence of a non-physical mind. Overall, the arguments in favor of dualism suggest that it's a compelling philosophical position, can explain a wide range of phenomena, and provide a more satisfying account of the nature of consciousness and mind-body relationships.
Okay, so it interpreted argument as reason in favor. I was thinking of like an argument as a collection of reasons for a conclusion.
Yeah.
So that's one initial difference, but I wonder you could easily get around that.
Yeah, I don't know. It depends on the query. Like we just asked it a simple query. You could, I guess, generate a bunch of queries and then put together an essay. But then again, it's a matter of taking that and crafting it into an argument or an essay. It's not just going to spit out the answer. You have to get creative, and then in that point, you're just doing the work. So,
yeah.
And I wanted to mention that there was, when I first started at Albany, there was a lot of plagiarism going around. A lot. Like, it was very surprising to me. I was like, oh my God, you guys are trying to cheat? Why? What's the point? And the way that they were able to catch people is, and I think it would work here too, Like there are certain ways of phrasing certain things that no matter how you doctor your query are always going to sneak in there. And so if you upload, so what they do in CS, and I don't know if they did this at philosophy, is they upload all the submissions to a database. And then that database is connected to, Stack Overflow, to chegg.com, all the different ways people can kind of just copy and paste stuff. And then it'll just check to see whose looks like the other ones and which ones are connected where. And so I feel like it might be very easy to actually find people who are using this if there's multiple people using it.
Yeah, we would use something like that would compare student submissions to other student submissions and, published things on the internet.
Yeah, in a way, like plagiarism detection is easier now because you have like tools. Before people would like write something, plagiarize it, and you couldn't tell for sure. But, yeah, that's great.
I would very frequently catch people because I could see that they copied and pasted because they didn't use one font. Like the style would change.
Yeah, it's like be a little less obvious and you cheat. That's the rule. Yeah. So that's great stuff. And it's like, again, and maybe we need like a GPT product or derived thing to catch cheaters. It's like the arms race. You have something that you can generate an answer with. You have to have something to check to see that that answer is genuine. So, yeah. And then this is
your bot generated paper to a degrading bot.
Yeah.
Don't need the professor anymore.
So Brian put this in this is his meme. Doctors Googling stuff online does not make you a doctor. Programmers. Yeah, it's great. Jesse put something. Hello, Morgan. How are you? So yeah, this is I put something in the pedagogy channel. So that was in this channel. Jesse said, yeah, so Jesse had something on GPT-3 being old news, but playing into OpenAI's chatbot is mind-blowing. So this is like, okay, so this is, I don't know if I'm sharing my screen. Okay. This is another one where, can you write me a 4-paragraph academic essay comparing and contrasting the theories of nationalism of Benedict Arnold and Ernest Gellner? So these are Benedict Anderson, not Arnold, sorry. These are two, I think, political science authors. Benedict Anderson and Ernest Gellner both have theories about the origins and nature of nationalism, but their perspectives differ in key ways. Anderson believes that nationalism is a cultural construct arising from the development of print capitalism. Gellner, on the other hand, sees nationalism as a product of modernization and industrialization. And then it says one key difference is between the two theories is the role of culture. And then this is the part where it kind of gets into some of these contrasting and comparisons. And then overall, while Anderson and Gellner provide valuable insights into the origins of nationalism, their theories offer different perspectives on the role of culture and agency. So it's constructing this essay. It's short. So, if you had an assignment where you said, generate an 8-page essay, I don't know if it would, you would really have like this kernel that you'd have to expand and work out. But I don't know what the length of the essay, like, I don't know how much it will generate with a given prompt. It seems like, well, this is 4 paragraphs, so you could probably generate like 8 pages, I guess, but I don't know what the quality would be. So this is, pretty, and of course, the more you generate, the question is, how good is it? Does it, replicate like an 8-page paper or 4-paragraph paper? 4-paragraph argument is actually pretty tight, but 8 pages might be a bit much, but I don't know. Jesse says, basically the conversation we just had, yeah, essay isn't that important. So yeah, that's just another nice example. Thank you, Jesse. So yeah, that was really interesting. Again, I wanted to point out, I have another thing here, the brain's behavior and complexity curriculum. I think we had a conversation, I think Jesse and I, about credentials and about learning. And he's looking at different programs that he can learn from. And I wanted to point out that we're still working on this brains, behavior, and complexity curriculum, and it consists of different things. Some of them are like, Neuromatch Academy. Some of these things are like, YouTube channels and other types of resources. Uh, this is not exactly the finished product that I would like it to be. I'd like people to engage with this as like a set of resources that on different topics, but I'd also like to be able to have like a system of like, I want to understand this topic. Like say complexity theory, I'm going to go to these resources, and some of these resources offer credentials, like just like certificates or badges, and some of them don't. But to be able to like go to these resources, learn from them, and then demonstrate your learning. So you know um, a lot of the like a lot of these short degree programs online will have like you complete a number of credits and you get a certificate or like a degree. I'm not really interested in conferring degrees, but I would like to have like, I think, a system where if you do some sort of self-guided education where you go to like a set of resources or tutorials and you complete them, you know, having that as like the basis for doing something else with it would be good. And that's really what we want to do. But having like a way to take that information and apply it to something, I think would be very useful. I don't know if that makes too much sense in the abstract, but basically, if I wanted to know more about network science for my research, I could go to these resources, and then whatever they offer, it would, some of them might have like a certificate attached. Some might be a set of curated materials. Some might be like just kind of going over the basics, to be able to demonstrate that you know those things, or to be able to apply them to something is really the end goal. So I want to make sure that people are using resources that are online, that are available, but also being able to apply them to things. And I don't know if that requires like a set of credentials or a set of like just exercises, or just leaving it up to people to do their own thing. Um, but I'd like this to be more part of what we do, because we talk about a lot of topics, and you know aside from just kind of like diving into the literature, which is inefficient, it's nice to have like a set of resources to draw from, to have like a sort of a shared level of understanding of these things. So we're kind of working on this educational aspect of the lab, and trying to help people navigate a lot of different topics as an interdisciplinary organization. And so this is kind of what we're drawing from. There are probably other approaches where people can go get like a certification in something like data science, a more detailed certification. And of course people are working on their own degrees and things like that. One thing I mentioned to Jesse is that one thing you can do is to, again, like something we've done in the group previously, but maybe putting a stronger emphasis on it, is to go to some of these references, learn from them, and then prepare like tutorials and other types of materials that that demonstrate your mastery. So one thing I did in the summer of 2020 was I created a series of lectures, and this was during the first NeuroMatch, where the first NeuroMatch was pretty much like the Wild West, because they had only done it for what it was like the first time they did it. So we had a lot of people coming through the lab that were like wanting to prep for NeuroMatch, and they were sort of didn't have a lot to do because they were on lockdown. So I actually prepared a number of lectures on different topics that were sort of augmenting what they were learning at NeuroMatch. So I did a net logo tutorial, some things on agent-based modeling, some things on Bayesian thinking, critical periods for development, collective behavior, and information theory. And like all these talks were sort of tailored to kind of the topics that they weren't necessarily getting in NeuroMatch. There were kind of auxiliary topics, but they also had a certain sort of flavor to them that were, in the spirit of the lab. So this is something that can be done to demonstrate mastery, but also, just applying them to your regular research. So, taking a competency exam is one thing and getting a certificate, but then there's this demonstration of mastery as well. So I wanted to bring that up, just to think it's more food for thought, I think, at this point. But it's something that's ongoing. We're trying to figure that out as a larger problem of education. Any comments or questions about that?
So are we thinking about doing that as a lab moving forward, I guess? Is that...
Yeah, I mean, I don't know, we've talked about the open house and we've kind of getting to the point where we've got that in place. We're not done, but it's like we've done that. And then this, next phase is like kind of, if people are interested in learning about new topics, how do you, where do you get your information from? Do you get it from Wikipedia exclusively, or do you go to like things that have been curated and have some sort of vetting to them? And then when you engage with those materials, then you just get a certificate and then say good luck, or do you use those skills? You can create something with them, like a paper or a talk or something, and then demonstrate your mastery in that way. And so this is something that we've talked about with mastery. We've talked about with credentialism and all this. And I think there's a way forward there, because when you're doing interdisciplinary education, one of the things you run into is you can go very deep into every topic, and that's good. But it's like maybe that's not the best way to really kind of, if you're trying to do an interdisciplinary view of things, maybe you don't want to get very deep into everything. Maybe you want to get just enough so that you know what you're doing, and then explore a couple of areas and synthesize them. So it's not something a typical degree program does well. They give you like a set of things that you learn, and then that's that. If you're in like a neuroscience program, you have to teach people everything, and they often run into the problem of what to put in the curriculum. We put a lot of molecular biology in the curriculum. Well, when you learn a lot of molecular biology, then you're not learning about the computational stuff. There was a point in neuroscience, like the last 20 years, where they said, well, everything is about molecular biology because that's the future. But there's a lot of stuff in neuroscience that's actually, fundamental to understanding the brain that isn't molecular biology. So how do you balance those out? It's something that curriculum committees always struggle with, because you have so many things you need to teach, and it's like you only have a limited amount of time. So yeah.
Well,
go ahead.
yeah, I'll kind of follow up directly from that, because the two links that I mentioned are interesting in their development. The first is like a Stanford degree that's, I think Bradley said, like, it's like a computer science degree with a little bit more like statistics or something like that, which is cool. The second is a actual master's in, I don't know if I posted the right link or not, but as a master's in, embodied cognition, master's PhD, which I don't know if it's one en route to a PhD specifically. Like you have like some places the PhD, places the master's, especially in Europe, are like you do this and then you do the PhD. I don't know if that's exactly that or not, but to bridge from what Bradley was saying is that I'm kind of tasked, and there's always the sort of how completionist do you want to be, either as a researcher or someone trying to build a curriculum for others to follow too. And there's sort of limits about that. And I guess I spent a lot of time the last week sorting out, well, not sorting out, but I guess reflecting the what do I want long term versus what are stepping stones midterm versus what's actually going to build out sort of theory or skill sets. And they're all actually, they all feel quite different to me, and they also have different very different levels of accessibility in terms of what I want to do. Like I feel fairly confident that there's a really nice amount of online degrees in computer science and data science that are reasonably priced. Some are very unreasonably priced. Some are very, just look like you're just throwing cash away at an extremely high rate. But that's not the same as a PhD, and that's not the same as some of the theory work that I might be interested in. And it feels like such a different array of options along all of these fronts. And what do you want to do? Because there's in the lab, and sort of like what Bradley mentioned in that space, and also sort of like the cognition future space, you could do a similar thing for like society, ethics, tech, or whatever banner we want to make. If we so chose to, we could be, let's make a curriculum for all of our major research banners, like the pedagogy and the Devo worm stuff, the development of bio stuff. I'm not saying we should do that. We probably should right now. But like they're from a like research administrative perspective or a guide perspective, those are things that sort of are at least latent or in the background of my mind a lot. So, I guess what I'll say, or there are a lot of ways this conversation can go, but I'll just conclude on the personal note of it's been really interesting to kind of reevaluate some of that, because I personally feel like there's absolutely certain, as I mentioned, I have been working a lot of different things over the past year, and recently some of that has changed and I have more free time. And I basically realized, excuse me, there's kind of it's not the same because of what we do in the lab, but there's this sense of almost like not being in school or not having a certain educational component that I have for many years. And there's been a lot of development of certain, for lack of better terms, yes, credentials, but also certain skill sets. And so now that I have time again and a realization of, like I have this whole year where I can be doing X, Y, Z. And yeah, if I get into a PhD program, then that'll be great. I kind of think I won't, but we'll see. I'm actually a little bit less heavily emphasizing certain things I want to do before and more other things. So it's just this sense of, where in what is accessible versus what kind of juries would you want to be in person for? What can you do online? What can you get like a function, like not a learning is degree based or certificate based either. And I was like, what's a good way to allocate your, for lack of better terms, credential pursuit within a specific arena? Like that's a big question for me right now, and I think it totally depends on a lot of your goals. Like it's not really, but like some things you want a graduate degree in blank, some things you don't, or it's maybe a waste of time or money to do that, and sometimes it's just whatever opportunity you can get. So that's what's on my mind about this stuff.
Yeah. It's definitely like what's worth like an entire degree and what's not. Like, and it's a personal decision. Sometimes it's like, am I really into this or not? Or is it really something that is worth me getting an entire degree in, or do I just need to take a class or two or, whatever. And it really depends on your personal needs and how you want to apply these things. So,
well, yeah, and I would even say, like, to be a little bit of it sounds like a little more derogatory than I want it to be, but to be, I'll say, a bit of a diva about this. I've I have found remarkably few PhD programs that really say this is what you want to do. And there are many good programs, but it's sort of like the degree to which I want to be saying and doing, I want to make the commitment to do a PhD ultimately. That's something I desire to do. But I don't know. I don't know. There's a lot to say about that, but it's just and it's not even so much like if I got into, the thing is, like, if I got into a PhD, like most of any PhD programs, I wouldn't, it'd be hard for me to turn it down in a sense, but at the same time it's like I think it's sort of just this question of understanding sort of it's not really the explore, exploit, payoff, but it's like, how much stuff do I need to learn in a certain way of doing things that maybe I don't want to commit my life to doing, but I have to learn in order to do what I want to do after it. And I think, I think I'm a bit spoiled with the cognition features stuff because that's a little bit of a loophole and then a shortcut to doing some higher level thinking and theory work that's fun and exciting, but maybe not the same as, doing other things. But then it's like, what do you actually want to do? Like, do you, if you're not going to be a tenure track professor, and if you're not going to be in a very specific way of doing things, then it's a different conversation. I don't want to. We can move on to a different subject. It's kind of mind dumping. All that.
Well, no, I think that's an important point about like how much do you want to invest in something to get an outcome, like, and that's something that I think if you're anyone who wants to do a degree in something has to consider, because it's like it's a certain amount of commitment, and you want to know, and this is different from like a bachelor's degree, because a bachelor's degree is sort of a base of knowledge, but like a professional degree or a specialized degree, like how much do I want to commit to this to learn something, and can I learn this in other ways? So it's not like just about there's one way to learn something. And I think it's very important for like interdisciplinary work where you have skills that are, and sometimes, even like theory building, you don't necessarily learn that in a degree program, right? Because like in cognitive science, I don't know if there are any programs where they have like a class on theory building. It's just something you kind of develop informally. And so that's another thing. Like you can develop the skill informally, maybe there's a curriculum you can take, but what is a commitment you need to make to learn those things and be competent in them? And that's, I think, the question, because even if you're in a degree program, there's certain things you're not going to get a class in, or there's certain things you're maybe not even going to do very much of because you have other things you need to do. I think statistical methods is another thing that's really kind of hard to get at the right level. In a lot of PhD programs, you can learn it from like the perspective of, say, like a psychology department offering a course on some technique, which is largely using a program like, like using R, using like, Stata or something, and like learning how to press the buttons, and then learning, maybe they'll throw some math at you and teach you the basics. But then if you go to the statistics department, it's a lot more math, and you may or may not get the application. And so like there's this bridge between the two. There's a gap between the two where there's no bridge really. It's just kind of like you learn it one way or you learn it another way, and it may or may not be useful to you either way. And it's like, how do you customize that for your needs? That's the
Yeah, and it's sort of like it dovetails a little bit into a conversation. Not really. It's just, it would be generous to call it a conversation, maybe a set of exchanges I had like with Johan John a while ago. So as I was talking about, like, what do you, as we know, I look up to Johan as someone who's articulate and well read and has written a lot and speaks really well about many things that I'm interested in. And it always seems to come back down to like, well, just like write or produce or create something. And like if you want to learn about it, that's sort of like the the completion of that is making something yourself in that way. And it's a bit like, it's not so much in a lot of ways, the questions that I have right now are complicated by nature of choosing a degree program, because a degree or a certificate, even like whether like various specializations in formal things, convey a certain amount of like respect or recognizability to other people. And I think that will be useful for some things I want to do now and down the road. But in one sense, that complicates the question of what do you want to know and what do you want to do? Because like that what you want to do changes so much. Like in one sense, like there is a perspective or a lens maybe that it's always just what's the next project you're working on in one sense. Like you can have a project of going through a course, sure, but and there are many different like project-based, et cetera, use-based research itself, like we talked about last time, I think. But like, it's kind of, in one sense, it's always just building on the next round of things. So, and like, okay, I'm on this project now, I'm doing this things. What can I learn that applies to this to make that thing go better? And cross-pollinating and all that stuff. So, anyway, a bunch of questions and very few answers in what I said.
Oh, no, I think that ties together. I mean, a lot of food for thought there, but like, I think there's definitely, I think it ties together a lot of the sort of the angst we've had about like curriculum building and a lot of the things that you get, a lot of the imperfections in the system that we have. And sometimes those are necessary, but still we can improve upon it, I think. Yeah, so I think that's great. Yeah, so we can talk about that offline more. And Jesse and I have just been talking about that this week in terms of both mentorship and like formal systems of education. So definitely, if you want to join in on that, you're welcome to. But right now, I want to talk about. I know Jesse, you went to NeurIPS this week, or you attended kind of vicariously. I don't know what the status was. I pulled up.
I was virtually at the event. I took a few notes. I haven't the last 2 days as much, but we talked. I think there was some discussion in the lab about the Chalmers thing, which is the bottom of the first day.
Yeah.
And there were a few others, but I feel like Chalmers and the first like new to ML one, which had Bengio talking about his sort of trajectory over the course of his career was interesting. Those are probably the most fleshed out things in the notes so far.
Yeah.
But I don't know if you want to go in any of those things or not.
Yeah, so this is the notion that Jesse put together. Thank you for putting this together. And this is, I guess, the keynote speakers here. So there's our large language model, Sentient. That was David Chalmers, and we've talked about his work on VR and some other things. And of course, this is we talked about the people who were talking about how maybe large language models are sentient. There was the guy at Google, I think, research who had made the claim or something like that. And it's an interesting question because I don't know. Maybe it's it seems kind of a ridiculous thing to say at first, but maybe not. Maybe there is a sort of aspect where people might think that this is a sentient system. So David Chalmers actually explored that in his talk. But there were some other things here. There were some nice. I was looking over the list of like the agenda, and there's some really interesting things. So let's see, what are some of the notes here? There was Women in Machine Learning, which was an affinity workshop. There was New in ML, which is this, for newcomers. This is, I think, the one that, I don't know if this is the one you're referring to, Jesse. This is the Bengio, DL journey. This is kind of, okay, this is, I guess, some of the slides from, is this like a different thing, or?
That's not the Bengio.
Okay.
Okay, wait, it might be. Yeah, okay, sorry. But I would go up to the top of it because I don't really know where we are.
Right here. There it is.
Yeah.
Deep learning journey. And this is
it was actually really nice. I didn't know he was going to be in this. I was kind of just looking at a lot of the opening workshops, and I didn't know he was going to be in this one. But it was a nice bit of perspective through stuff. I'm actually going to pull it up so I can see myself.
okay. Falling in love with a research direction. So this was his journey. Reading papers, zooming in on an area, reading papers on some of this early stuff, and then kind of working through his degrees, and keeping up with the community. Went to the summer school in 1988, did a PhD thesis, and then it says neural networks and AI, extraordinary and exciting hypotheses. These are principles giving rise to intelligence by learning simple enough that they can be described compactly in an equation or in a model. Similar to the laws of physics, our intelligence is not just the result of a huge bag of tricks and pieces of knowledge, but of general mechanisms to acquire knowledge. So I think that's an interesting thing that, you have this statement sort of why you're doing this. Like people usually, one of the things that people do is they usually have an overarching question that drives their research. Sometimes not. I mean, you don't have to, but if you're doing something that's kind of a big picture relevance, sometimes it's important to have that kind of statement to give yourself to keep yourself oriented, I guess. And then just to keep, so you have a longer term vision of where you want to go with this. So yeah, this is a nice little talking about distributed representations, power compositionality, machine learning and AI leads to deep learning. 5 ingredients for ML towards AI, 5 key ingredients, lots and lots of data, very flexible models, enough computing power, computationally efficient inference, powerful assumptions that can defeat the curse of dimensionality and achieve strong generalization in new cases. So these are, again, like having these not necessarily posted on your to-do board, but like just having like these different things that you want to accomplish is always good for a longer term research program.
It was sort of a nice, he at one point in the talk he addresses some of his going back and forth. He talks about some of the big problems he worked on, and he goes back towards the end of it. I think he explicitly says, he's kind of going through the timeline stuff and the some of the winters, and then 2012 happens, and but there was a slide at the end called persist and pull the truth, or persist and pull the threads, and it was kind of explaining how through the AI winter, things will ebb and flow, but it's important to keep trying to make. I would scroll down a bit more, or I'll just share my screen or something. But
oh yeah, why don't you share your screen?
I don't think this is necessarily groundbreaking for any of us here, but where did it go? Well, I'll just show this and we'll kind of move on after this probably, but you can see this, yeah.
Yeah.
The persistent pull deferred was sort of a nice, one of the takeaways was for some of this was how important it is to really get good questions, and how following your intuitions is always really important, but having the tools to validate those questions experimentally, mathematically, and other ways, so you can share and get feedback from other people. Like that's where a lot of the hard work is, especially when like you're kind of going through like winters or summers for different ideas. And this sort of pulling on the threads carefully, asking why, and understanding, and recognize the importance of just Spore group, who's like Canadian research group here. So I think that's a good lesson for a lot of the work that we're trying to do ultimately too, which is like we have intuitions we're following, like in conditioned futures or whatever, but the message project is a nice centerpiece because we're looking for how do we get to putting these things in terms that we can. It's almost like the doing this work affords certain discussions we want to have. And actually, what I was thinking before is like, kind of prior to this NeurIPS thing is sort of the difference between like a curriculum as developing a set of skills you need to know versus having it be more of a conversation of not developing a curriculum, but almost like developing a conversation or developing your ability to be a part of the conversation. Like, what is the conversation? Where is the conversation gone? But how do you actually do it? And I think this is actually quite adjacent or in support of that, because you have to sort of have the skills and the know-how to form the next point of interface such that the conversation can actually move forward. Like that seems to functionally be what it's really about. And he didn't, he put it in his own words here, but I feel like what he was talking about in this whole presentation was basically about that, which is pretty cool. He talks about GANs and attention and stuff that we were very versed in, and about being humble and how words are distractions. Yeah. And just dimensionality, causal representation is something he's working on. Out of distribution, generalizing beyond the training distribution, and brittleness and stuff like that. And I think that's pretty much it. And this is conscious processing, minding the gap between state of the. This is sort of framing a lot of the what is the gap between state of the art and human level intelligence with these things here. And that's pretty much his talk. He gets into systems too, like Daniel Kahneman systems 1, systems 2, and some of the issues there. But and his latest thing is the G flow, and he talks about social impact, which is pretty cool. But yeah, that's what that talk was basically about. It was just a nice. I think it's really nice. If you said Benjo's giving you a talk on the flow of things, like yeah, that's what I expect. But I think it's because it's like particularly unexpected and slightly different words than I've heard before, so it was fun.
Yeah, I think that's really this whole business about developing skills versus conversations. I think is really interesting because we talk about skill building. Kind of education is skill building, but of course it's also about discussions and about like other things that are more talking about issues, arguing, reasoning. So that's also very important, and kind of keeping that in mind is key. It's not just like a bunch of multiple choice questions or generating an answer, as we've seen. Yeah, so that's part of the sort of the credentialism too. Is like how do you getting to a place where you're learning something isn't necessarily about credentials or about giving the right answer. It's about getting the struggling with the questions and struggling with the sort of the issues that you need to address. And yeah. So yeah, that's great. Let me share my screen again. I was going to bring up one more topic here before we get into papers. Let's see. So there was this, I don't know if anyone's heard about this, but there's this thing called, there was this platform called Spore. It came out about maybe 13 or 14 years ago, I guess maybe 2008, 2009, where Maxis, which is the creator of SimCity and The Sims, they came out with this video game called Spore. And this was supposed to be, if you're familiar with artificial life, if you're familiar with the simulation of living systems, and we've talked about that with respect to like different Alife platforms, and we've talked about different collective behavior simulations. We've shown those. This is what they were trying to achieve here. This is with this game called Spore. And Spore was a game where you would create life, and from like basically some molecules, you'd create these organisms, and then you'd shepherd their evolution throughout time. And so this is Samuel Arbesman. He has a lot of really interesting things that he talks about and writes about. And he was talking about these old Spore prototypes from Maxis look like a cornucopia of emergent microcosms. So these are some things from this game. These are some scenes where they're generating these organisms, and they're showing collective behavior. You can also, I think, design the environment as well. So you have this world where these organisms interact and evolve. And so it's really, I was really fascinated by it when it first came out. It's like they're evolving in this environment. You can create them, and you can do a lot of the things you do with like The Sims or SimCity, where you control the environment, you give them resources, and you can shepherd their evolution. So it's really interesting. It's not exactly like biological evolution, but it's a really interesting approach to this. It's a simulation platform more than anything else. So having bringing that back into my mind, I went to the Spore website, which is spore.com, which is this. So this is the game here. This is Maxis. It's a little dated, this website, because I don't think they've updated it in a while. But this is basically the platform. And you can actually, over time, people have created their own universes and organisms. So the organisms look really interesting. They're not like organisms we see in the real world. They're just kind of, some of them are like lunar landers, and you have different machines, and then you have like different organisms. The Robotiter, Wodo Dragon, different things like that you just allow to evolve and assemble. So you can do a lot of things with this platform. And then they have these prototypes. So this is the thing he mentioned in the tweet. This is play with our prototypes. So Spore has been a huge undertaking. Along the way, we ended up exploring countless design directions and gameplay, simulation, and user interface. One of the ways in which we explore possible design directions is by building simple, playable prototypes that we can play around with to get a sense for a particular system. So we're simulating a system, a living system, but we want to create prototypes for people to get started. Usually these prototypes are never seen by the public, but we thought some of the more intrepid players out there might enjoy playing around with a few of the early Spore prototypes. Keep in mind these are not tested, supported, or even easily explained. So this is like a lot like the philosophy behind NetLogo, where you have this platform that simulates things. You create like some agents, you create an environment, you introduce some parameters, and then you let it run. And you don't really know what to expect, but you have this environment where you can not only do this sort of simulation, but interact with the simulation as you go along. So one of the things about NetLogo is the interactivity, and they talk about that in terms of constructivism, like where the user is constantly giving feedback to the system and shaping it. So this, there were a number of prototypes here that they have. tide pool, texture box. So texture box, for example, this prototype demonstrates the application of simple paint program style tools to dynamic cellular automata systems like biome and cell culture. So you can use this to paint with these sort of systems. Tide pool is represents our first steps down the path towards synthesizing our ideas into a playable game. So this was originally sort of this is sort of the origins of Spore, where they sort of started with this tide pool, which is where you have simple life evolving in it, and then they moved on to Spore, which is more complex. Tide pool combines a forest fire simulator from Biome with the terrain and water simulation from Waterboy. So the forest fire simulator is something you can do like in NetLogo. It's a agent-based model. Terrain and water simulation comes from like the video game world, where you're simulating these different aspects of the environment. And then the flocking system from Crowd, and this results in a firefighting minigame. So again, flocking is something you can implement in NetLogo, but you don't have this sort of these environmental simulations like terrain and water. So this is combining sort of those two worlds and bringing them together. Net City, which is actually a programmable simulator used to explore the evolution of complex behavior from simple components. So this is kind of more like a traditional agent-based simulation, but they've actually used Soda Constructor, which is another thing that I might talk about in a future meeting. But Soda Play is an interesting. I don't think this is in service anymore, but I think there's a emulation of this somewhere, and I have to find it. But Soda Constructor was where you could build these skeletons, these like sort of organisms that were like skeletons that were like springs, and they were like these creatures that you built out of springs, and these lines are the springs, and these nodes are kind of like the base of the spring, and they were physics simulators where you could build these organisms that would walk around. They'd scurry around in different ways depending on how you built them, and you could evaluate them for their structural integrity. This was fun to play with, but it's something that it's a different type of simulation. You can incorporate this into something like an agent-based model, and then of course you can take inspiration from Vehicles by Valentino Breitenberg, which is of course we've talked about vehicles a lot, but basically it's this idea of an organism that has sensory inputs and effectors which move. So given the sensory input, there's movement in a certain direction, and you can bootstrap all this into a really interesting sort of artificial intelligence system. So there are a lot of templates that they tried out, and I think this is just fascinating because it goes back like a while, but you're combining all these different types of simulation, like agent-based modeling, these sort of Alife approaches, physics simulators, and even like video game simulators, and you're putting it all together into like a platform that allows you to simulate intelligence and simulate like embodiment, things like that. So, any questions about that or comments?
I saw that a while ago. It's so interesting. I love that stuff.
Yeah. Yeah, I think it's really interesting thinking about like how to bring these different models together. Like, you're doing like a physics simulator, but you're also doing like agent-based modeling. You're doing also other things like even like more conventional neural networks and AI, bringing that all together in one place. So, okay. Now I wanted to get to papers. And I know we talked about this several weeks ago. We talked about this in Cognition Futures. We talked about mirror neurons, and I'm going to give a couple papers on it, and I'm not going to do it justice probably, but I wanted to go over, I think these are some papers that were sort of the early papers of mirror neurons that sort of established the field. And like I said before, mirror neurons, were very hot maybe 30 years ago, maybe 25 years ago, where people were like first discovered them and then sort of ascribed it to everything that involved consciousness or some sort of I guess that was the goal, was to connect it to consciousness, but they had a lot of putative roles back then, and since that time, it's kind of the hype has kind of died down around it, and so then the question is like, well, what are these things that we call mirror neurons? And so some people debated. Oh, thank you, Brian, for attending. And so the debate is like, what are they actually? Sometimes when you make a discovery, it's really exciting, and everyone says this is a great new discovery, and then people tend to apply it to everything, and then when the hype dies down, and it's like technology, like AI technology, when the hype dies down, you figure out exactly what you're dealing with. So that's something to keep in mind here. This is the first, actually, maybe I don't want to start with that paper. This is a review from the Philosophical Transactions of the Royal Society B. This is the citation. This is from 2014, and this is kind of a retrospective on mirror neuron research. So this is mirror neuron research, the past and the future. This is part of a special issue that celebrated the discovery of mirror neurons 20 years after the first report of their discovery. So 20 years before 2014 is 1994, and that's when they first discovered this. I think these are the two people who discovered it. All articles in this issue have been updated and deal with the present state of the art of mirror neuron research in different fields. So this is a special issue, mirror neurons, fundamental discoveries, theoretical perspectives, and clinical applications. So if you want to check that out, that's up to you. But it's probably pretty insightful. Even more difficult was to forecast that the discovery of mirror neurons would have an impact on disciplines outside neuroscience, such as psychology, ethology, sociology, and philosophy, or that they would interest novelists. I think we talked about like how this inspired art and literature, as well as conventional science and philosophy. So, outside of maybe your standard cog-sci cognate fields, it was going into art and literature, which is kind of interesting for a neuroscience concept, because we typically don't think of, well, I mean, I guess there's some neuroscience concepts that go outside of science, but it's just kind of interesting how it diffused so quickly. Why is the notion of mirror neurons had such a wide impact on cognitive disciplines? Two reasons are the most likely. The first is that their discovery put the problem of how we understand others at the forefront of neuroscience. The second is that by showing that mirror neurons were basically motor neurons, they suggested a rather unexpected solution to this problem. The motor system is involved in understanding the actions and intentions of others. So this assumes that we know what a mirror neuron is, and so the definition of a mirror neuron is that you're sort of able to, so there's a motor neuron component. We'll see in the paper, the original paper, they actually were looking at like fictive motion and copying the motion of others and copying sort of the things. If you look at someone else, you're sort of mimicking their behavior, and there's a motor component to it. And so this was thought as like something that was really involved, like maybe empathizing with others or understanding others. So this was the original definition of a mirror neuron. This problem of how we understand others is not new in philosophical debates. One of the most accepted views is that the capacity to understand the intentions of others is based on the observer's capacity to infer others' internal mental states. So there's a tie between mirror neurons and theory of mind, and ascribe them to a causal role in generating the observed behavior. So this is where you're inferring mental states, and you're ascribing them to different types of motor action, which are visible in the body of the other person. So that's basically what mirror neurons do, I guess. And so boiling this down to a single neuron, of course, is a very reductionist activity, but it's also necessary to get a handle on this sort of neural substrate that's involved in these sorts of things. This view is in line with the analytical tradition based on the propositional accounts of others' minds. An alternative view put forward by phenomenologists is that we understand others by comparing an action done by others with our own behavior in similar situations. So another reason why we might be interested in these mirror neurons is that they allow us to compare, allow us to infer maybe what other people were thinking, and then figure out how to act in that situation. So you're comparing your own internal state or your own thinking with someone else's thinking and what they do. This discovery of mirror neurons did not disprove the conventional analytical view, but demonstrated the validity of the phenomenological stance, at least in most everyday life conditions. It's important to stress that action understanding through mirror mechanisms is a direct activation of motor representation. It does not require a cognitive simulation of others' behavior as suggested by simulation theory of action understanding. So there's this competing idea of simulation theory for theory of mind, where you have to simulate other people's thinking, and you have to get into their brain and then think about what they might think about. So it's a very meta thing. But with motor neurons, or with this model of phenomenology, when people are thinking something, they act. And so you can see it in the body, you can see it in the motor activity. And so then you can mimic that, and it's sort of a conformational step that you don't have with just simulating things, because you can simulate things in a lot of ways and misunderstand them that way. So yeah, interest in the direct understanding of others' actions increased enormously when it was found that the mirror mechanism is also present in the emotional brain centers. So this mirror mechanism is actually linked to the emotional processing that we have. There's no doubt that one can understand others' emotions by inferential mental processes. There is clear evidence that brain structures involved in the integration and control of emotions, such as the insula and the anterior cingulate, which are brain regions, respond both when one feels an emotion, say pain or disgust, owing to natural stimuli, or when one observes the emotion in others. So if you see someone with a look of pain or disgust on their face, then that allows you to know that they're feeling pain and disgust, and maybe how to act in that situation. So, viewing someone's facial expression, of course, is a signal. It's a social signal, but it's also something that you can infer someone's internal mental state from. This mechanism allows a direct first-person understanding of others' emotion. Your pain is my pain, which would be like the social aspect of it. So then, some authors have questioned the presence of mirror neurons. We may be able to do this without mirror neurons. I mean, they're not required, but this is the thing that, is sort of this reductionist aspect. There's got to be some sort of thing responsible for all these things. And so that's why we're interested in mirror neurons. This is not, however, a current issue, given the overwhelming evidence for the existence of mirror neurons. So mirror neurons have been basically proven to exist. The question is, what do they do? And how, central are they to that process? So, they've been able to figure out from hundreds of experiments using a variety of techniques, imaging techniques that are listed here, that they exist. So they've been confirmed and validated using a number of techniques, a number of different experimental paradigms, even single neuron studies. So this is a very, there's been a lot of work on mirror neurons over this period. They've been very much, in support of the existence of mirror neurons. We don't necessarily, getting the function down is always challenging. So, yeah, then they kind of go over a lot of this, talking about some of the aspects of the motor system and some of the roles that mirror neurons play. That, some people have thought that the motor system has been traditionally considered not to be involved in cognitive functions. So this is something that's relevant to our discussions on embodiment and on motor control. We've talked about motor control in the context of like the Fuchs book, and some of the stuff that we've talked about with dynamical cognition. And we say, why do we need a body? One of the reasons we need a body, aside from like having a case for our brains and action, is that there are very specific motor functions that were it's not just this fuzzy thing about like action. There are different aspects of the motor system that are linked to cognitive function explicitly, and that's not traditionally been thought to be the case. People have thought of the motor system as sort of this sort of basal function that like reflexes when you hit someone's knee with a hammer, your knee, your leg flexes, and that's the way a lot of people thought about the motor system traditionally. But it's actually the case, and it's become increasingly evident that the motor system is actually involved intimately with higher level cognition. And so the discovery of mirror neurons and other types of specialized motor neurons, like say neurons encoding peripersonal space or transforming object affordances into motor acts, which are called canonical neurons, have changed this view. And now you have this motor system that's much more connected to higher level cognition. It's a really interesting point because we talk about this in Fuchs as if it's kind of like an article of faith or just kind of like this thing that oh yeah, of course, obviously motor control is involved in, it has a link to, or embodiment has a link to cognition, but we never really, kind of explore why that is, or maybe the traditional views. And of course, we have this evidence across species, sort of, I don't know if they're motor neurons, so marmosets, for example, have shown some evidence of having precursors of motor neurons, mirror neurons, I'm sorry. So they have mirror neurons in their ventral premotor cortex, and that suggests that they're primate origins of mirror neurons in humans, as well as in other species where you have these same types of phenomena potentially. So it's not just in humans where the motor system is linked to higher order cognition. You see this in other species. You also see this in terms of language production. So in songbirds, which are used as a model for language production in humans, but it's in birds, they sing their songs in a way that humans produce language, and language production and song production are linked to higher level cognition. And so there's this interesting connection there as well. So there's a lot of interesting stuff that involves motor neurons, but more generally, the motor pathways and motor production and higher level cognition. So this is another review from Behavioral and Brain Sciences, also from 2014. This is mirror neurons from origin to function. And this paper actually gives larger historical views of the other paper, kind of discuss the evidence in context. This one kind of walks through mirror neurons from their discovery to some of the things that they do, some of the things we've found evidence for, despite the hype. So we've actually refined the function of these neurons. The intriguing feature of many mirror neurons is that they fire not only when the animal is performing an action, such as grasping an object using a power grip, which is like, grasping a tool with your whole hand, but also when the animal passively observes a similar action performed by another agent. So this is, again, this mirroring behavior. We argue that mirror neurons are forged by domain general processes of associative learning in the course of individual development. And although they may have psychological functions, they do not necessarily have a specific evolutionary purpose or adaptive function. And so, the evidence supporting this shows that mirror neurons do not consistently encode action goals, per se. So they're not part of the motor planning system, necessarily. The contingency and context-sensitive nature of associative learning explains the full range of mirror neuron properties. So it's very it's connected to associative learning quite explicitly. And then developmentally, human infants receive enough sensory motor experience to support associative learning of mirror neurons, what they call wealth of the stimulus, which is interesting because there's this developmental perspective when we've talked about how motor learning is key to human development. And so this is, again, it plays an intimate role in this area. And then 4 mirror neurons can be changed in radical ways by sensory motor training. So training can actually change how mirror neurons respond. And so this is, of course, behavioral and brain sciences paper. So that means that there's a lot of comment at the end. So if you go to the end of the paper, I don't know if this copy has it, but there's going to be like this long and detailed, not just the review itself, but response by different people in the field. So if you want to understand a little bit more about the debates in the area. So this is the open peer commentary, and you're going to have like probably about 20 pages of this where people debate what they've talked about in the paper, and they bat it around, and it's really, this is a really valuable thing to read. So one comment is associative learning is necessary but not sufficient for mirror neuron development. They really going to drill into some of these issues. So this is something to check out if you're interested in some of these issues. And then finally, this paper, which is, I believe this is the first paper. Well, no, I didn't include that one. But this is actually this third paper. So the original paper was in 1994, and it involved some experiments. And I don't have that paper in this collection, but this paper is actually mirror neurons in the tree of life. Mosaic evolution, plasticity, and exaptation of sensory motor matching responses. And this paper, so just to briefly talk through the abstract here, considering the properties of mirror neurons in terms of development and phylogeny, which is the evolution of these mirror neurons from a common ancestor. They use the term phylogeny. We offer a novel, unifying, and testable account of their evolution according to the available data and try to unify apparently discordant research, including the plasticity of mirror neurons during development, their adaptive value, and their phylogenetic relationships and continuity. So we've talked about all these already, that there's this aspect of mirror neurons being sensitive to experience and development, having this phylogenetic aspect where you see this in not just humans, but in like other primates and in like birds, and you see this sort of phylogenetic aspect to these cells. So they're not human specific. And then this continuity of these types of mechanisms. We hypothesize that the mirror neuron system reflects a set of interrelated traits. So it's not just mirror neurons, but other traits, each with an independent natural history due to unique selective pressures. We propose there are at least 3 evolutionary significant trends that give rise to 3 subtypes: hand visuomotor, mouth visuomotor, and audio-vocal. So these are different types of mirror neurons based on looking at sort of how they evolve, mirror neurons together with other traits. So if you're observing a conspecific, you're observing different aspects of their motor behavior, and they have to respond to sort of, there has to be some selection for this. So what are the most salient signals that a conspecific can give for different types of behavior? So, we've talked about the social aspect, but they're also like the hand, the mouth, and audio-vocal stimuli. So if you see like the hand of a conspecific moving towards some piece of fruit, or putting it in its mouth, or making a vocalization, those are all important aspects to maybe behavior that's useful. And not only social behavior maybe, but also survival related behavior. So specifically, we put forward a mosaic evolution hypothesis, which posits that different types of mirror neurons may have evolved at different rates within and among species. This evolutionary hypothesis represents an alternative to both adaptationist and associative models. So we talked earlier about how there's an aspect of associative learning. It's a little bit different, and this hypothesis is a little bit different than that, in that there's this strong evolutionary relationship between mirror neurons and the emergence of different types of behaviors, motor behaviors, not just social behaviors. Finally, the review offers a strong heuristic potential in predicting the circumstances under which specific variations in properties of mirror neurons are expected. Such predictive value is critical to test new hypotheses about mirror neuron activity and its plastic changes, depending on the species, their specific neuroanatomy, and the ecological niche. So this really kind of opens the gates in terms of like how mirror neurons are distributed in other species other than humans, kind of giving a broader view of this across phylogeny, and giving an idea of how this is useful to animal behavior, where you have variation in social interactions, but also variation in motor control and motor behavior, and of course higher level cognition. So this is I'll put these papers in the chat or in the Slack with the meeting recording, and you can explore those a little bit more if you're so inclined. Yeah. So any comments about that or questions?
The evolutionary perspective is really interesting. That's not something I know much about. But I'm wondering, like, if you can distinguish between different types of mirror neurons from an evolutionary standpoint, like what consequences might that have for the philosophical discussion of mirror neurons? Because I've seen a lot of philosophers, some do this very well and some do it very poorly, like try to draw conclusions about a philosophy of mind, but also things up to like morality from mirror neurons. So yeah, I guess I'm just wondering how that discussion could be informed by the evolutionary science.
I think like what they do in evolutionary neuroanatomy is they look for like different analogic or different types of homological areas in the cortex. So, they'll say that this area of the human brain is, equivalent to this area of some other non-human primate brain, and then they'll like trace out the function. And what they're saying in the from the phylogenetic perspective is that mirror neurons are flexible in terms of their function. So it's not just like there's a focus in humans on like the social cues and maybe some of the specific motor control things that we do. Like we use our motor systems. Our motor systems are actually really refined compared to some other primates. Like we can control our movements a lot more, and we have motor control is connected more with like things like I'm not going to get into that, but basically it's different from what you see in non-human primates. And so, making those analogies, it's kind of tricky, but you can, bring evidence to bear to show that there's like an analogy that these cells are kind of have a common ancestry and that their function is divergent. But then the question is, well, how divergent is it? Do they have all these different? Because it seems like what mirror neurons are doing are just mimicking like the behavior of others, or you're able to infer the behavior of others from their motor control, their motor cues, and then being able to implement that in your own brain. So maybe that's important for foraging in one species, but important for like social functions in another species, or maybe there's a little bit of both in each species. It's really not clear, but I agree that perspective really does open a lot of avenues for thinking about that. Yeah. So, anything else? Yeah, Amanda, that was a very good insight. Thanks.
What did Amanda say? I missed part of it.
Oh, it was just we were talking. Oh, go ahead.
The short version is how can the evolutionary science inform the philosophical discussion, philosophical conclusions drawn from about mirror neurons and empathy and stuff.
Okay.
Okay. Anyone else have anything before we go?
That's all. Good to hear from everybody. I'll catch up on the meeting. What did we talk about in the first like 30 minutes or so? Just
well, Brian actually gave a presentation on his project, so you might want to check that out.
I'll do that.
All right.
But otherwise, see everybody next week.
Yep.
Bye.
Have a good week. Thank you.
See you soon.
See you soon. Bye.